So very good day to everybody. Once again, this is technological innovation and new media. And in this class, we discuss about image fusion, about how you try to secure the image. Then we discuss about steganography concept. Actually, we are going to hide the details in the image. Okay. Then we discuss about watermarking. Okay. So this is especially for you, my students and young researchers, and you can reach me at dr.christoananth@gmail.com. So before beginning the session, once again, let me thank God for giving me this opportunity to deliver this useful session, share my knowledge among my fellow national, international participants, students, and young researchers. So in this class, we'll discuss about image fusion, how you will go with image fusion using the command line, how you try to restore the images by the fusion from the fuzzy images, and we'll discuss about steganography concept. So that is, as I told you, hiding the details in the image. Okay. And you have some terms which are describing the image steganography. Then we have video steganography as well, where you try to store the details, or we hide the details in the video. Okay. Then we'll have some steganography examples as well. Then we'll have digital watermarking and its types. What are the process? What are the life cycle that is being followed? Then of course we have some advantages and disadvantages. So at regular intervals, I'll be giving you some short videos to discuss the knowledge in our topics. Right. So this is image fusion, where you are going to merge this wavelet decompositions of two original images, okay, using the fusion methods. Here you will be using approximation coefficients as well as detail coefficients, where you are going to store the details in the image. Okay. So here the two images, definitely it should be of same size, and you can be associated with this indexed images on a common color map, so that you will be using a W extend function to actually resize to the similar images. Okay. So here two examples are examined. Okay. First one, you're going to merge two different images that you will try to find out as a new image. Okay. And second one, you are going to restore it to the two fuzzy versions of the original image. Okay. So here is the first thing. So example one, will have the fusion of two different images. So one will consider a mask and then a bust. Okay, so the load, you're going to load the mask. Okay, so x1 equal to x, and you're going to load the bust. So x2 is equal to x. Okay, so what you're going to do, you're going to merge these two images from the wavelet transform, okay, at level 5 using this db2 by taking two different fusion methods. Okay, so the fusion, you're going to have both approximation as well as details. Okay, so x fusion mean is equal to w fusion image x1 x2 db2 phi mean and then mean. Then you'll go with the fusion by taking the maximum from the approximation and maybe minimum for the details. Okay, so here if you can see x fusion max minimum, w fuse image, okay, x1 x2 db2 phi max and then minimum. Okay, so this is how you will go with the plotting the original as well as synthesized image. Okay, so here you will be having color map. Okay, so subplot 2 to 1 image x1 axis square, and then the title you will have mask. Similarly, you are going to repeat for the bust. So subplot 2 to 2 image x2 axis square, title you will have bust. Okay, then you will have subplot 3. Okay, so that's 2 to 3 image x fusion mean you are going to calculate. Okay, so then you will have axis square, the title you will have synthesized image mean. Okay, then you will have subplot 4 where you will be having x fusion maximum minimum, the axis square, title the synthesized image maximum minimum. So here if you can see, this is the mask and this is the bust, so identify the difference between them. Okay, then you have the synthesized image, that's the third one, 2 to 3. Okay, will have the mean. Okay, then you'll have the synthesized image maximum minimum. So the fourth one is actually the smoothing the image. Okay, then you will have the synthesized version. Okay, right. So here actually what you are going to do, you are going to consider an original image, then you will go to blurring the image, then you will go with the restored image. Okay, and you will go with the blind deconvolution. Okay, so in order to store the details, hide the details in the particular image. Okay, so here you will go with the restoration by fusion from fuzzy images. So load cat, okay, the one, okay, so x1 equal to x. Okay, and this is another one, Catherine. Okay, Catherine 2. Okay, x2 is equal to x. So here you are going to merge the two images from the wavelet decompositions at level 5. So just in the previous case, okay, using symmetrical 4 property. Okay, and you will go with the approximation. So x fusion is equal to WFU's image x1, x2, symmetrical 4. So last type we had symmetrical 2 type. Okay. So 5, max and then max. Okay. So here you are going to plot the original as well as synthesized image. I will show you. Okay. So this is actually Catherine 1, Catherine 2, and this is the synthesized image. So for the first one, here it's blurred. Second one, here it's blurred. Okay. And this is how you are going to synthesize from the Catherine 1 and Catherine 2. Okay. So color map, you will have the subplot. Okay. 2 to 1. Image x1, axis square. The title you will have Catherine 1. Okay. And second one, subplot 2 to 2. Okay. Image x2, axis square. Title Catherine 2. Okay. So subplot you will have 2 to 3. Image you will have X fusion. Okay. This is the synthesized image. So here it's actually a restored version of the good quality of the common original image. So as I told you, steganography, it's a this is what many ethical hackers are actually doing into. Okay, so they are trying to hide the sensitive information within the ordinary non-secret file or maybe message as well, that it will not be detected. Okay. So here the sensitive information is actually extracted from the ordinary file or maybe message at the destination, and you can actually avoid the detection. Okay. So steganography is of course an additional step that can be used with the encryption standard in order to protect the data. Okay, so similar to the files that you use. Okay, so images or maybe videos also, you can also protect the data. Okay, so here you are actually going to store the secret information. Okay, or maybe you can also go with the non-secret document as well, or maybe any media to avoid the detection. So just by seeing the video or image, you cannot see that details in the image. Okay, and this is how it goes. So steganography, that word comes from steganos. It's a Greek word. Okay, steganos means hidden or maybe covered. Okay, and graph, steganograph, graph means you're going to write. Okay, so you can call it as the hidden writing or maybe secret writing. Okay, so you can use steganography maybe to hide text. You can hide content. Okay, in the images, video, even audio even. Okay, and of course you can understand the standards given. We go with steganography. Actually with the case of text, we are going to store them. Okay, so that you are going to secretly store this information. So the hidden data is encoded into the letter of each word. Okay, even in the case of image image steganography even. Okay, so you are going to hide it in the image of a different object. Okay, as a cover. Okay, so maybe the pixel intensities where you can actually store this details. Okay, so that you can call it to be the image steganography. Okay, then you'll have cover image as well. So that's a unique picture that can actually conceal the data. Okay, and you can have real data as well, where you can actually mask within the pictures. Okay, or maybe images. So here the message can be in the form of standard text or maybe a image. Okay, then you have stego image as well. So it's actually an image with a hidden message. Okay, then you have stego key. Okay, so just like a serial key, you can actually store them. Okay, and messages can be actually embedded in the cover images and maybe stego images as well with the help of a key. Okay, so here the message can be derived from the photo themselves. So this is the audio steganography. Okay, you'll have these several methods: least significant bit, echo hiding, phase coding, spread spectrum, tone insertion. So these are actually the methods where you can actually hide the details in an audio. Okay, so you can actually store or maybe hide the data in the sound as well. Okay, so when used digitally, definitely it is going to protect against the unauthorized reproduction. Okay, even in the case of YouTube, even if you are trying to copy one audio library, okay, if it is licensed under some license, like for example Creative Commons attribution license. So when you are trying to hide the details, even in the audio even, for example, if you have to protect against this reproduction even, okay, similar thing happens in the YouTube library as well. If you are trying to store it in the library and if it has a license associated, okay, you can actually protect from reproduction. Even it will show the copyright even. Okay, so that comes from this audio steganography. Okay, so you can actually involve this media playback, audio clips even you can go with. Okay, where you can actually encrypt one piece of the data, the message, within the carrier even. So video steganography also you can use it. Even in the video also you can actually secretly embed the data or maybe any other files within the video file. Okay, so Same like an audio, you can actually function as a carrier, okay, and you can use DCT, discrete cosine transform, where you can insert the values, you can hide the data in each of the image in the video, okay. So maybe in the several file formats, like maybe MP4 format, MPEG, AVI, or maybe H264 standard, you can actually hide the details. So it is actually aligned, okay, with this TCP, UDP, Internet Control Message Protocol, or maybe Internet Protocol as well, where you can take it or maybe store it, okay, in the form of the open system interface layer network model as well, okay. So these are some examples where actually you can write with invisible ink as well, so that you can take as an example of steganography, okay. So you can embed the text in a picture, okay, just like an artist in a modern photography or maybe modern art, you can actually hide the details in the painting as well, okay. And you can go with backward masking, you can actually decrypt and you can get the message in the audio file. I think you would have seen some movies, even like conjuring type of movies, even they show this type, okay, playing one audio, playing another to another audio, and playing both audios at the same time, you will get one information. So this is how you are going to conceal this information in either the metadata or maybe within the file header even, okay. And you can also go with hiding an image in a video, okay, so that you can go with, and you can also embed the secret message maybe as a green channel, red channel, or maybe blue channel as well in the RRB image format, okay. So you can use it for the constructive as well as destructive purpose as well, even with the case of educational or maybe business organizations or maybe institutions, intelligence agencies, especially that is associated with the government, okay, the military, and of course certified ethical hackers even, okay. You can use steganography to embed the confidential messages and of course information in plain sight, okay. So you can actually go with the steganography, okay, to corrupt the data files or maybe hide the malware, so that you can go with the smaller and maybe general innocent documents. And you can use several tools as well. So there are several tools, Stego tools, which are available online, okay. So this is StegHide, it's actually a free tool, okay, so that you can conceal this information in the files, media, or maybe text even, okay. Then you have Stego Suite, so that's a Java based free steganography tool, okay. So you can actually go with hiding the data in the pictures, especially for the storing the purpose, okay. Then you'll have OpenPuff, okay, so that you can go with the hiding in the images, videos, and flash animations as well, okay. And then you'll have Zeo steganography, so that is how you'll go with storing and maybe hiding the information in the BMP images or maybe WAV files as well. So that's a free steganography tool. Right. So next we'll have YesSuit Pixel as well. So that's also how you try to hide the text within the image file. Okay. Then you can also go with the digital watermarking as well. Actually, you can embed this digital media, okay, like audio, video, image as well, where you can have a watermark. Okay, so you can know who is actually the source, who is actually the owner of that particular copyright event. Okay, so you can also use this technique in order to trace this copyright infringement, especially in the social media, and you can know which are the genuine things or maybe genuine notes, okay, especially in the banking system, okay. And you can have visible watermarks as well, so that you can display it in the video, okay, so that you can have, okay. And you can have invisible watermarks as well, so that you can embed in the media, and of course you can use the steganographic technique, okay, in order to get what is actually hidden in this media, okay. Then you'll have public watermarks that you can use algorithms to commonly retrieve it, okay, but definitely public watermarks are not secure enough, okay. Then you will have fragile watermarks, so that you can, while going for data manipulation, you can actually destroy these watermarks, okay. And there should be a system to identify, okay, the changes in the data if fragile watermarks are to be used. So even you can embed this in the media even, okay, so that's what you call to be the digital watermark, okay. So here we have three main parts. One is you are going to embed, okay, so that where you are having this digital signal which is embedded into the digital watermark. Then you'll go with the attack, okay. So when the transmitted media has actually changed, it becomes a threat, and of course it's called as an attack of the watermarking system. Then you go with the protection. Okay, so you are going to detect the noisy signal, and that what has actually changed, that you are going to protect it. Okay, so you whenever you can go with JPEG compression or maybe rotation, scaling, cropping, adding noise. So this is how you'll go with the protection from the noisy signals. Okay. And of course in the applications in the forensic science you can actually use them. Okay, and you can use it in the brands, even brand logo, brand images, that you can use it. Okay, and of course digital watermarking, you can use it, you can prevent somebody from infringing or maybe prevent somebody from copying the data. Okay, and normally in the video editing, normally you'll be having these types of watermarks, both public as well as invisible watermarks as well. Okay, especially in the video authentication, when somebody is trying to copy them, that you can protect them. Okay, even in the ID card security, especially when it has like some codes that are associated, of course you can use them. Even in the CMS, content management system, in the social media, that you can use it. Okay, especially in the Insta and then YouTube. So of course you can use it in detecting the copyright infringements, especially of the digital content. Okay, so of course it's a very secure technique. Okay, and you can use the key especially for the embedding even. Okay, so no, anybody who wants to actually remove this watermark can actually work on the keys, especially in the embedding. So if you can use an embedded version, of course it's digital, you can easily transmit and you can use it easily. Okay, and there will be no change in the file format even, which means that there is no error or maybe much more no difficulty in using the watermark medium. Of course the disadvantages, it is easily to be removed and of course overlaid by other watermarks. So maybe if you put out another watermark, then definitely you can actually disturb or maybe entire scenario even. Okay, so there should be more development and enhancement, especially with the robust techniques, to actually watermark the pictures. Okay, and the pictures with watermarks, it can easily resized, you can actually place a color even. Okay, and you can actually crop the watermarks easily even. Okay, and owners also can easily remove the watermarks. Okay, it's easy to manipulate the image, and of course you can alter the watermark even.